Hello everyone. In this session, let us discuss series and parallel connection of elements. First, let me introduce you to the definition of series and parallel elements. Two elements or two or more elements are said to be in series if they have the same current flowing through them, and two or more elements said to be connected in parallel if they experience the same potential. Potential in the sense voltage, right? So if they experience the same voltage. So this is the actual definition which defines series and parallel elements. For series elements, for elements to be series, they all should carry the same current, and for elements to be in parallel, they have to experience the same voltage. But in reality, it is easier for us to identify series element because we said same current is going to flow. So whatever current that flows here does not have any escape route. It is going to flow through this resistor also in case if you have such a connection. And what happens if you have a branch arising from this point? So if you have a node, so node is said to be a junction or a point where more than two elements meet. So when you have a node between two resistances, then they cannot be in series because whatever current that comes here is going to get divided into two, right? So hence you cannot say same current is going to flow through these two resistors. That is now impossible, and hence you cannot have two resistors to be in series if you have a node in between them. But now, talking about the parallel case, it is little difficult to identify. Most of the time students make a blunder that if such a circuit is given, they tend to say, I don't know how they understand this, but somehow like this they understand, and they say these two resistors are connected in series, but they are not actually connected in series. They experience the same potential. If it is really hard for you to understand that, okay, check with the value of current. So a current is going here. Okay, it is coming to this node. Whenever you have a node is going to split the value of current, right? So one portion of current is going to flow through this resistor. The other portion of current is going to flow through the other resistor. If the current that has split has again come back and if it joins at the other end. So current is splitting into two, and then those two parts are again combining together, then such a connection is said to be a parallel connection. So let me explain series and parallel connection using simple circuits. So now let me take this problem. So originally current is going to come out of this voltage source. So it is coming here, and this value of current, okay, as it comes to this node, it gets split into two. Okay, one portion is going to go through these resistors and the other portion is going to go through this resistor. Now it again splits into two at this node, right? So if you see here beyond this point, there is no splitting. So let me stop here and let me start to reduce from this point. So what is happening here? The value of current that comes here is going to flow through both R6 and R7. So the current through R6 and R7 are the same, which implies R6 and R7 are connected in series. Okay, so before that, let me give you the formula to calculate the equivalent resistance if your resistors are connected in series. If R1 and R2 are connected in series, okay, if they are connected in series, then the total resistance or the effective resistance is equal to R1 plus R2. So this is one familiar formula which we have been seeing since we were in our school days. And for parallel, 1 by RT is equal to 1 by R1 plus 1 by R2. Okay, or you could write RT is equal to 1 by R1 plus 1 by R2, the whole inverse. Okay, so if it is going to be 3 resistances, it is going to be plus R3. Okay. Plus 1 by R2 plus 1 by R3. Okay, so that's going to be the case. So now let me proceed with the simplification. So here, as you could see, R6 and R7 are connected in series, which means R6 plus R7. So it is 4 ohm. So now let me redraw the circuit. So now I'm going to redraw the circuit. Okay, so I have the voltage source 5 volt, 4 ohm, 4 ohm. Here you have an 8 ohm. And then here you have a 10 ohm resistor and R5, which is 4 ohm. And now we have reduced this portion, right? We have combined R6 and R7 and we have found that to be 4 ohm. Okay, now looking at this, you could see that whatever current, so let me again come from here. Okay, so I have a value of current. Okay, so this current is coming to this node and then it splits into 2. So it splits into 2. Okay, and this portion of current is going to go through this 10 ohm resistor. Now, after coming to this point, it again splits into 2. Okay, so the current splits from here. Okay, it again. Okay, so one portion is traveling here, the other portion is traveling here. Immediately at the end of these two elements, again these values of currents are going to again come back and join. So it means that these two resistances are connected in parallel. Okay, so let me reduce. Okay, so here I find 2 4 ohm resistors to be connected in parallel. So I have here now 2 4 ohm resistances, right? So 1 by 4 plus 1 by 4, the whole inverse. So which is equal to 2 ohm. So now I have reduced these two resistances and I have found the effective value. So now let me redraw this circuit. Okay, so I have a 5 volt, 4 ohm. Here I have a 4 ohm. Okay, and this is the portion that I have already simplified, right? So here I have the effective resistance which I have calculated, which is 2 ohm. Okay, so now again start. Current is flowing from the source So it comes here to this point, splits into two. Beyond this point, there is no possibility for the current to split. And if you see here, so let me use a different color. So if you see here, whatever current that flows here is going to flow through 2 ohm also. So originally a current came from the voltage source, came to this node, got split into two, and the portion of current that is coming to 10 ohm is again flowing through 2 ohm also. Okay, so here whatever the current you have, it is flowing here, and similarly, okay, so whatever current we find here, whatever current you find here in 4 ohm, that is going to flow through 8 ohm. So let me combine two steps together and say 8 ohm and 4 ohm are in series, and 10 ohm and 2 ohm are again in series. Okay, so now let me find if 8 ohm and 4 ohm are in series, then adding both together, you'll have 12 ohm in one branch, and in the other branch, it is again going to be equal to 10 plus 2, which is 12 ohm. So now let me simplify the circuit further and draw here. So whatever I haven't touched, so 5 volt, and here 4 ohm. Okay, so this point, so here you have 4 ohm and 8 ohm together, right? So which is added together to give 12 ohm. And here we have another 12 ohm. Okay, so now you could see here that these two resistances are connected in parallel. So again, go back. So see that a current is coming from this voltage source, comes to this node, gets splits into two. Okay, and at the end of these elements, okay, blue color element and rose color element have their ends here. At the end of these two elements, you have again these two currents combining together. Okay, so we say that these two are being connected in parallel. Okay, so I find two 12 ohm resistors in parallel, which means the effective resistance is 1 by 12 plus 1 by 12, the whole inverse, which is equal to 6. I'm not wrong. Okay, so 6 ohm. And now, as you could reduce these two and draw it as one resistor, the simplified circuit is going to be 5 volt. Here we have a 4 ohm resistor in series with 6 ohm resistor, because whatever current flows here is going to flow. So the total resistance of the given circuit is 10 ohm, and the voltage is given as 5 volt. So the current that comes out of this battery, if I call it as I, it is equal to V by R, applying Ohm's law. So that is equal to 5 divided by 10, which is 0.5 ampere. Okay, so this is how we could use series parallel combination to find the total value of current that is supplied by the battery. So now let me explain one more problem. So here in this problem, you have a voltage source here. So current starts to come out of this voltage source. Okay, so it goes through this 2 ohm resistor. It comes to this node. Okay, so at this node, your current splits. Whatever current gets splitted here, okay, so one portion is going to flow through this path, the other portion is going to flow through this 30 ohm resistor. Finally, they are going to again combine together at this point. So after this point, they are going to flow, right? So current gets splitted into two, and the two portion get combined here. So we could say that these two resistances are connected in parallel. Okay, so let me quickly draw the equivalent circuit alone. So here I combine R2, 3. Okay, so I combine R2 and R3 and I write it as R23, where R23 is the parallel combination of R2 and R3. Okay, and we draw the rest. So here you have R1 and then here you have R4 and you have the voltage. So if you see here, now current comes out of the voltage source. Whatever current that comes out of this voltage source is going to flow through R1. The same current is going to flow through R23 and that same current is flowing through R4. So I could say that R1, R23, which is the parallel combination of R2 and R3, along with R4 are all connected in series. And now let me quickly explain for this problem. So it is given here, current I is coming out of the battery, that is the voltage source 3 volt. So when it comes to this point, so at this point, the current is going to split into 3. Okay, so current splits into 3. So this current is going to flow through this 30 ohm and it's coming to point C. And similarly, this current, blue color, it is also passing through this 30 ohm resistor and it's again meeting at point C, which means these two resistors are connected in parallel. Okay, so now let me reduce. So the parallel combination is between, I have combined AE and CD together, right? So I write it as AE and CD. So the parallel combination, so 1 by 30 plus 1 by 30, the whole inverse is 15, if I'm not wrong. Okay, kindly verify using your calculator. And now I draw the remaining 15 ohm. So here you have point B and here you again have another 15 ohm, okay, connected through C. And then here you have a 3 volt. Okay, now coming back, here you have a current coming from the source, you call it I. Okay, that current, when it comes to this node, gets split into 2. Okay, so one portion is flowing through this 15 ohm resistor, the other portion is flowing through this 15 ohm resistor. So whatever current that flows here is going to flow through this resistor also, because here you don't have a node. A node is said to be a point where more than 2 elements meet. Here only 2 elements meet and hence this is not a node. So if you don't have a node between two resistors, then whatever current that flows here is obviously going to flow through this resistor also. So whatever current we had here, that is again flowing through this resistor, and I say that these two resistors are in series. Okay, so now if you reduce, okay, so that's going to be, okay, AE, and here, okay, so these two are in series, right? So I just combine these two, okay, add 15 plus 15 series, right? So I add and I have 30 ohm. Okay, so 30 ohm is the value of resistance between AE and B. And again between AE and B, according to the diagram, you have another resistor 15 where you have this current. Okay, so 3 volt. So now looking at these two resistances, you could say that they are in parallel. So after reduction, you will be in a position to find the value of current I. Okay. So series parallel combination is mostly used to find the total current which is supplied by the source, or it is also used to find the value of power delivered, and thus we use series parallel combination in order to simplify circuits with only one source. Here in all these problems, we had only one source. So such circuits are solved by using a series parallel combination. Practice more problems to be really proficient enough in order to solve complicated problems also. Thank you all.